So in the previous class, I told you the traffic engineering is the feature that allows you to use all available paths whenever there is necessity instead of passing through the same path, instead of passing through the same path which the routing table always shows. You can pick the alternate paths which is there in the link state database if the route in the routing table do not have enough bandwidth. Here we can see switch 1, switch 2, 3 on the top, 4, 5. To reach 5, switch 1 can go directly. After 2, it can go straight to switch 4. But we see here there are two tunnels. Tunnel 1 is going via the below path, tunnel 2 is going via the upper path. This may be because, the congestion was too much between 2 and 4. To avoid congestion, traffic that goes inside the tunnel 2 will take an alternate path. So the tunnel 1 traffic can easily go. There won't be congestion between 2 and 4. In case if the bandwidth is available for tunnel 2 traffic on the same link which is there between 2 and 4, both the tunnels will use the same path. This tunnel 1 path is then maybe preferred path for tunnel 1 traffics. We have path options. For example, the traffic X matches, it will use tunnel 1. If traffic Y matches, it will use tunnel 2. So tunnel 1 preferred path is this, tunnel 2's preferred path is this. That we define in path option. If in case this router goes down, tunnel 2 will have path option 2, which is this below path, provided enough resources available. So tunnel 1 is already using this path. But assume that the resource which is necessary for tunnel 2 to be served, if it is available, even tunnel 2 can be configured to use this as the backup path, if resource available. If not, the packets are going to be dropped, there is no doubt. This is also traffic engineering. In the previous class, we did not see this scenario. We saw a little bit different. What is that? By default, when there is no traffic engineering, OSPF gives the shortest path. See here, the cost is 1, 1, 1. So to reach this destination, if you go this below path, the cost is only 3. But when we take the upper path, the cost is more than 3. The cost is more than 3. So OSPF will always use the low cost path. But the problem is if every traffic, thousands of traffic, if all traffic is using only this path, then this path is wasted, idle. Yeah, little costly, no doubt in it, but instead of waiting in this congested road and getting dropped, the traffic could have been passed like this. The traffic can be passed like this, but the problem is, by default, OSPF cannot do. That's why we mix traffic engineering RSVP along with OSPF. That also we saw. We use routing protocol, which is a link state routing protocol. Because the link state routing protocol only maintains the complete database of the links in the topology. So the recommended protocol to do this is only link state. OSPF or ISIS is what recommended. So the second thing what we are seeing here is the tunnel can also be mapped to a path. Whether there is a heavy traffic here or not, if traffic matches Y, it should only take tunnel 2. And tunnel 2 is always this one, the preferred path. Always. Preferred path is this. In case if this fails, then the path option can be dynamic, meaning the routing protocol showing path. Then routing protocol will show this path and packet will go this way. So this type of customized policy-based path selection, not only policy-based path selection, this type of QoS you can only achieve through traffic engineering along with link state routing protocol. Fine, now let us see what they're saying here. Simple MPLS traffic engineering tunnel configuration. This is what they're going to show you both ISIS and OSPF configuration example. Enhanced shortest path first routing means constraint based SPF. Constraint based SPF, meaning you got a constraint like I need at least 20 meg. Now show me those paths that has got 20 meg in which pick the shortest 20 meg available path. You may have many 20 meg available paths. Pick the shortest among them. This is what called as enhanced SPF routing over travel. Okay. RSVP cannot discover the topology by itself. So it needs the help of a link state routing protocol. That's why you need ISIS or OSPF. Secondly, RSVP cannot generate label. RSVP can only check whether there is enough resource available, which is needed, is available among the paths, and reserve the path for you. By using SPF algorithm, it will pick the path with the low cost also. So it needs MPLS for the label. So RSVP depends on MPLS as well as the link state routing protocol. These are all things that we saw in the previous class. I'm going to just show you the configuration example. First, we'll start with OSPF because you know OSPF better than ISIS. If you see here, I want to start from OSPF. Simple commands, 2 line. We need to say use the router ID so that this also will become the part of the same database, OSPF database. And then traffic engineering is going to use area zeros database. Already you have LSDB, no? So this is going to use the complete database of OSPF area Z. Multi-area is not recommended for traffic engineering. These are just two commands that you need to put: MPLS traffic engineering router ID, and it's the address which is also used by OSPF as the router ID. Now you are giving for OSPF MPLS traffic engineering to use the same, and then share the database, area zeros database with traffic engineering. That's all. Very simple command. Next is Ceph is already enabled, no worries. You don't need to worry about that. MPLS traffic engineering tunnel in the global configuration mode. And then under the physical interfaces in the path, we say MPLS traffic engineering tunnels, and we say how much bandwidth you want to give. We need to say how much bandwidth that we want to give for traffic engineering to utilize. See, this bandwidth is not going to be blocked, but when a traffic comes, this is the maximum amount of bandwidth that RSVP can claim from this particular interface. Any question on this?
No, sir.
Right. Now, the tunnel configuration. Still, the configuration is not over. Only the OSPF side is over. OSPF side and the traffic engineering configuration over the tunnel interface, sorry, the physical interface. Now, the tunnel may have a dynamic path, or you may have a path option. Here you see the path options. I go inside the tunnel interface and I say use the LUBAC 0 as your IP address. And I'm also giving the tunnel destination with which I need to negotiate the tunnel. If you see the picture, this is the tunnel destination router 5's address. I'm right now doing on router 1. Tunnel mode is MPLS traffic engineering. See, this is usually GRE, tunnel mode. We are switching to MPLS traffic engineering. And then this is the constraint. Look at this. This is big difference between this one and this 1000. This 1000 on the physical interface is not only for this tunnel that you are creating. There may be many tunnels using that physical interface. For tunnel 1, I want 100 meg available bandwidth. But that command, which in the top, it is telling that's the maximum bandwidth RSVP can use. See, if we have 5 tunnels like this, constrain 100 megabits, then 500 will be consumed. There will be still 500 more for 5 more tunnels. So this is not the constraint, please understand. This is the reservation that you are doing for RSVP to consume on fast Ethernet. You are saying this is the maximum that RSVP can use. I may have 10 gig there, but I'm saying no, you cannot use 10 gig, you can use only 1 meg. 1000 is 1 meg actually, isn't it? This is just this is not in KBs, kilobits, not in MBs. Okay. So here we are saying 1000 KB, and here the tunnel needs 100 KB. Traffic that is using this tunnel demands 100 KB path. And then priority lower is always preferred. We'll talk about priority later. Now, path option is what I'm trying to focus. Here, we are not giving any precise path. We are saying tunnel 1 should follow dynamic path, whatever the routing protocol has given. So routing protocol will always give the low cost path, right? That is why it has taken this path. Now, for tunnel 2, you write explicit go upper way. Upper way, going upper way is not normal. Dynamic routing protocol, they don't give long route, more cost. They don't give. They always give low cost, not more cost. But if you want this path, the path with more cost, to be your preferred path, then you need to write this path option, explicit path option. See the IP address 200.1, which is going out from here, exit interface, and it hits 172.16.0.1, which is this exit. It hits second router. When it goes out, it hits the second router, and then this is the exit you give. And then the other exit 01, which is here, 0.1, and then 10.0.0.1, this exit. So you're mentioning the explicit path by giving the exit interface IP address of all the devices in the path as explicit path. Now this explicit path will be your path option under the tunnel interface. You see, for tunnel 2, for the same destination that you had in tunnel 1, same destination, all these are same. This is it. Explicit identifier 1, which is this. Yeah. So after you configure, you can verify by using this command show MPLS traffic engineering tunnel. It will show all the tunnels. If you want to see particular interface, the tunnel interface status, you can type this. Any question? It's very easy configuration. No? We have finished actually. What? Using OSPF, the configuration. Using OSPF, we have finished. Now we need to see ISIS. If you don't have any question, we'll go to ISIS. Do you have any question on OSPF?
Sir, I have one doubt here. Sir, when we configure the tunnel, we give the source as IP unnumbered loopback 0, and then
Which
we
is
specify the
also IP unnumbered
destination
on the remote site.
IP address also.
Loopback 0. This 200 or 288, 228 is also a loopback
remote site
address.
Yeah.
Which is used as IP unnumbered on switch 8. Yes, please.
Yeah. So here there is
That's
no
why we said
configuration
IP unnumbered. We don't
of
want
IP
to
address
give
for the tunnel.
an IP address. We want to use the IP address which is already there in loopback, which is already pingable. Yeah, so the loopback interface IP address itself
so that
becomes
will
the
be
IP address
used.
of tunnel interface. Yes.
Okay.
Jay, Jay, does OSPF help anyway in this traffic engineering to create
MPLS
labels,
only
or
you
we
need
have to
to
depend on MPLS?
And these MPLS labels will be carried by OSPF. That's the extension that is done to the OSPF header. When you give that command, MPLS traffic engineering area 0. When you put these commands, the MPLS traffic engineering fields gets created in the OSPF header. You remember we learned opaque LSA? In OSPF, LSA type 9, opaque LSA.
Sorry, Jay, say that again.
They are the one who is carrying the labels.
Opaque LSS, yeah.
9 to 11. No, 9 to 11 is
9, 10, 11.
only. So
What about 11?
they
9 to 11.
they distribute the label for the new
Opaque
path,
LSS, yeah.
which is not actually by the routing table, which is not by default by the dynamic routing protocol. This new path is because of traffic engineering. So for this new path, the labels need to be to get distributed. MPLS can only generate the label for the recommended path recommended by RSVP. For the path recommended by RSVP, MPLS can only assign labels for the new path, but the label distribution is carried out by OSPF itself or ISIS. ISIS also have got additional extension TLV, type length value, in the header so that it can carry labels. There will be a new database created for the traffic engineering when you put this command. See, it is easy only when we spend more time with the lab. We can really master this. We'll get some confidence on this. See how easy it is. Just 2 lines of configuration under OSPF. Other things are traffic engineering commands. If you want to use OSPF, this is the 2 line that you need to know. Now let us do ISIS. That is also 2 line configuration. If you go to ISIS configuration, you say router ISIS, all this. This is very important. Metric style, wide metric. And then it needs to be single area, right? So L1 is more than enough, but it's not a mandatory command, recommended. IS type L1, metric style wide, MPLS traffic engineering router ID level 0, MPLS traffic engineering, instead of area 0, you put level 1. Other things are same, you see. Other things are, there is no difference in the other configuration. Okay. So